In this video, we will create a keyboard input helper class. The purpose of this class is to take the state-based input that XNA provides when working with the keyboard and translate that to event-based input to make it easier to build an editor. So the purpose of this class is going to be to take in a call from update and generate events which can be subscribed to in another class. So to get started, let's go up here to our editor folder and we'll add a class. This class is going to be called keyboard input. Now here in this class there's a few things we need to do to get the class set up. The first of which, we'll pull out the sub namespace editor. Second, we need to drop in some using statements. So we'll drop in using for Microsoft.xna.framework as well as framework.input. Now inside of the class itself, we are going to make the keyboard input class static, so we will mark the class as such. Now before we actually jump inside of keyboard input, there is a delegate that we're going to define, and this delegate is going to be used in conjunction with the events that the keyboard input class is going to generate. Basically, we want a delegate that has parameters that will be relevant to us in terms of reading input. So we will define this delegate here as delegate void key handler. And let me correct this the naming on key. So the key handler delegate is going to have a method signature of two parameters. First is going to be a keys parameter. We'll call this parameter key, so this will indicate the specific key that was pressed to generate the event. The second one is going to be a keyboard input, or excuse me, keyboard state parameter called key state. The idea with key state is, in addition to the key that has been pressed, we will still have access to the entire state, so we can see if an additional key was pressed. This is useful for things like modifiers. For example, if we saw that the Z key was pressed and was the one that generated the press event, we can also see things like maybe the spacebar was held down at the same time. Alright, now we are ready to move into the keyboard input class itself. And we need to begin with some fields. All these fields will of course need to be static because the class itself is static. The first field is going to be a list of keys called bound keys. So here we have list keys called bound keys. And we will immediately initialize this list using a field initializer. So bound keys will equal new list of keys. Now, the idea behind bound keys is we're going to store all of the keys that keyboard input should be responsible for watching. And the idea is that rather than use all several hundred keys, or well, not several hundred, but I think technically it's 160 keys that we watch for in the keys array, rather than looking at all of them, we're given the option of only binding specific ones. And this will, of course, make the loops that drive our input much more efficient. So we can tell it specifically what keys to watch for. Alright, next up, we need to store the state of the keyboard between update calls, so we can detect when the state changes from released to pressed or from pressed to released. To store this, we're going to create a static field of type keyboard state, and we will call this field last key state. Alright, moving on from here, we need to have the actual events which can be subscribed to. So we will make some public static event fields of type key handler. These are going to be first key press. Now as we create these, we're also going to create some anonymous methods to immediately wire the handlers up so that these events can be called without checking first if they're set. So we'll say that key press is going to be equal to delegate, and we need to specify the method signature, so this will be keys called key, and a keyboard state called key state. And then for the body of this anonymous method, we will simply create empty brackets. Again, the idea is that this anonymous method will get linked in, so if we were to fire off the keypress event without first subscribing to it, technically we already have subscribed to it here internally, and so we get no errors. Now we need to do the same thing for key release, so I'm going to copy the keypress definition and paste it in and simply change the name. So this will change to key release. So we can set this to be, again, an anonymous method already assigned and ready for use. So these are the two events that we'll need to fire from inside of keyboard input. Now before we move on to the methods that will be held within, we're going to create a series of properties that will act as, you could say, helper aids to accessing some special keys on the keyboard. In the case of the Control, Shift, and Alt keys, we have two keys, one on the left, one on the right side of the keyboard. For the purposes of our editor, we don't want to worry about whether the left one or the right one was hit. To us, they're going to be exactly the same thing. So we're going to make some properties that return true if either the left or right key is pressed. So we'll make a series of public static properties. These will be Boolean in type, and the first one will address the control key. So it's going to be called control down. As a matter of fact, looking at this, to follow the semantics of the keyboard input a little bit closer, of course we have methods that are named things like is key up and is key down. To follow that naming scheme, I'm going to call these is control down, or rather this one will begin as is control down. That'll make it make sense as we look at it in code. Now inside of this property, I'm going to define the whole property inline to keep the code more compact as we scroll through it. It's also going to be read-only, so I'm only going to create a get accessor. And this get accessor is going to return either the left control key being pressed or the right control key being pressed. Of course, to look at the state, the only state information that survives between update is last key state. So we actually have to look at the last key state to check the control key in this case. So we will check last key state dot is key down, and then we'll pass in the key of interest, which is keys dot left control. So we're checking to see if left control is down, or if last key state dot is key down, passing in keys dot right control. So check for the left or for the right. Now we can close off our get accessor. So scrolling back over here just to review, we're currently inside of this get accessor. We finished off our statement, so we need to terminate that statement, excuse me, and provide a closing brace to the get accessor and one final closing brace to the property. So there are two braces, and on the beginning, the matching two braces. And then one thing to note with that, of course, we only have access to last key state, which seems to interfere with the concept of always getting the most up-to-date key press. But on one hand, last key state is never going to be more than one tick behind. And also, you look at this in terms of when it was called. Meaning, if you call keyboard input before calling something else that may depend on it, like mouse input, technically you are looking at the current state for this tick. Because as soon as update's going to get called, last state will get updated, and then last state will at that moment in time be equal to the current state. Just pointing that out since the naming semantics seem to suggest that that key state is going to be later than the current. Alright, now that we have is control down defined, I'm going to copy it and duplicate it so we can address is shift down. So we'll simply change the name of the property and then change the keys that it addresses. So left control will become left shift, and right control will become right shift. Now, one final property is going to be the alt key. So for this last property, again, we'll simply change the name to is alt down, and look at the keys as keys dot left alt and keys dot right alt. Alright, with those three lines assembled, we should be ready to move on to the actual methods. So the first method we're going to address is called addKey. This will be a public method, and here inside of the class it needs to be static. We're going to have no return, so we'll give a void return type, and we will call the method addKey. And we will pass in a single key as type keys. Now the idea with addKey is the addKey method will be used to make the keyboard input aware of a key that it should watch, since of course bound keys is going to begin life as an empty list, which means we're looking for no keys. We'll use addKey to add keys into the bound keys list, and then that will make keyboard input aware of those keys. So the method here in addKeys is simply boundkeys.add, passing in the key value. As a matter of fact, just to follow the naming scheme, I'm actually going to pull this back to just key. So key here is of type keys. Then we can pass in the key into boundkeys.add. Alright, moving on from here. In addition to being able to tell at any given check whether or not Control, Shift, and Alt are down is of course very useful. We would like to be able to do the same with any key passed in that is part of the key's enumeration. Now, we don't want to add an individual property for every key that's possible, so we'll assemble a method that takes in a key and asks the last key state if that key is currently pressed. So we will make a second public static method. This time we will have a Boolean return type, and the method name will be isKeyDown. And we will pass in a keys parameter called key. And all we need to do is return what last key state thinks of the current key. So we will return last key state dot isKeyDown, passing in the value, which is the parameter, key. Again, this is really just giving access to the last key state, which in our keyboard input class is private. Alright, one last method to address, and that is the update method. We'll assemble an update method by making a public static method with a void return type, and we will call the method update. Now, inside of update, we need to sample the current keyboard state and compare it against the last keyboard state in order to look for changes. So we'll begin with a local variable of type keyboard input, keyboard state, and we'll simply call this variable key state, and we can turn around and initialize the variable by asking the keyboard for the current state using the getState method. Alright, now that we have the current key state, we need to loop through all of the keys that we are currently watching inside of bound keys and see if any of those keys have changed in state. So we will assemble a for loop. We'll use the index variable I, and we will loop through all of our bound keys. So that will be boundkeys.count. Now, as we look through each key, the idea is that we check key state against last key state. Now, to make sure that last key state stays up to date, we do need to make sure that at the very end of our update calls, last key state gets set to be whatever key state currently is. So it's basically between these lines here is where the difference will appear between current key state and last key state. So it's in here that we need to check for changes. Now the first type of change we're looking for is in the case that the most up-to-date state is listed as down and the previous state was listed as up, because that would indicate that we just changed from up to down, meaning we need to generate a key press event. So let's put this check together. We'll make an if statement addressing key state, and we'll say if key state.isKeyDown, then we need to pass in the current key, which will be addressed here as bound keys sub I, since we're using the index variable I to look through all of our bound keys. So you can almost read bound keys sub I as current key of interest. So if that key is down and last key state dot is key up for that current key, bound keys sub I, then we have a scenario where the state has changed from up to down and we need to generate a key press event. So we'll simply fire off the event key press, Now we need to pass in the parameters to satisfy the key handler delegate. So this is going to be the current key, which again, bound keys sub I. Then we also need the overall key state that this key was found in, so we will pass along the full key state value as well. And again, this is where having an already assigned anonymous method inside of keypress is useful, since we don't have to do any additional checks before we use keypress. We already know that it has at least our anonymous method here, making it ready to fire. Alright, now this takes care of keypress. Now we need to address key release. So we need the opposite series of events, a key going from down to up, indicating a release. Now, this code is very similar to the key press code, so I'm simply going to duplicate the key press code and change around some of the methods. So first off, we're checking the current key state, and if a key has just been released, that means current state is going to be up. So we'll check is key up for bound keys I. Then the last key state is going to be, looking here, is going to be currently down for the current key. So again, saying the key right now is up, the key in the last state was down, the key has just been released. So we need to fire off the key release event. So key release for bound keys sub I passing in the key state will take care of firing the appropriate event. So with this now we have all of our class for our keyboard input handler assembled. I'm going to hit F6, make sure that everything gets built and saved. We're not showing any syntax errors, so this has our keyboard input taken care of. Of course, we'll be using this class in later videos, so we're going to go ahead and call the video here at this point, which will of course wrap up the keyboard input lesson.